What holds atoms together? There are no mysterious force that holds them together. The answer lies in the reaction to every action.
Just what do I mean by that?
We are all familiar with this science experiment when we were at young age. Filled the glass with water, cover the top with a flat sheet of cardboard, and turn it upside down.
It was surprising to witness during that time that the water couldn't just fell off. Later did we realize that in order for the water to come out from the glass must suck in air at the same time, which pulls the cardboard upward. Without a way for air to enter, the water won't flow out. As simple as it may seem, but this is the principle behind atomic bond. Every atom crystallize when they are cold. Their boundaries can be seen as cleavages. Cleavages determine how crystals are more likely to break. These cleavages are airtight, if I use the right term, preventing air from coming in, thus avoiding them from breaking apart. How does nature achieve such airtight space between atoms? One example of a material with strong atomic bonding is iron, which, when refined into steel, is considered one of the most reliable and widely used building materials in the world.
In Walter Russell's work on the periodic elements, he describes iron as a split tone located in the 7th octave, specifically on the male side, situated between the 3rd and 4th tones. In this area of high pressure, iron needs 4 units of oxygen from the lower 5th octave, which represents the female side, to balance its pressure. When this balance is achieved, iron appears in nature as salt.
Iron in its combined form with oxygen doesn't really serve a purpose until we break it down or change its balanced state.
By subjecting iron to its melting point, its balanced state will be divided, separating negative from the positive. Oxygen, being negatively discharged, tends to evaporate and spread apart, while iron, which is a positive charge, tends to stick together and draw closer. This separation creates a sort of tension, similar to how rubber stretches out and wants to snap back to its original state. When iron is suddenly exposed to a cold environment, it begins to cool, and as it begins cooling, it starts to expand, pushing against each other and forming crystals in the process. By preventing oxygen from rejoining its balanced partner due to the tight gaps between the iron atoms, a strong bond is formed. Over time, as everything seeks balance, oxygen continuously finds its way into tight spaces and bonds with iron, leading to rust formation. To prevent this reaction, we use coatings or introduce different materials that minimize the chances of oxygen mating with iron, which is one of its natural partners.